Some of these queries had tens of thousands of values, which is huge, right? Having a where query where you're looking for a value to be one of the values that you're providing, and the number of values that you're providing is in tens of thousands. Recently, I came across this blog by GitHub Engineering, which talks about how they upgraded their entire MySQL fleet of servers from version 5.7 something to version 8.x. They had to do that because the version that they were using, version 5, was coming to an end of life support phase. So they had to upgrade, and they faced a lot of challenges. So in this video, we're going to talk about how they planned this upgrade, how long it took them, the kind of challenges they faced, and we'll see what you can learn as a software engineer, or if you are an architect and you are supposed to plan things ahead, you are supposed to plan for such large upgrades. If that is the kind of position you're in, then this blog would be really useful for you, so keep watching. Now, this is a blog on the GitHub's blog page. I'll link this blog post in the description. They launched this in December 2023. So this is not the recent blog. This is about over a year old, but it's still very relevant. A lot of things can be used even right now, because if you see, GitHub has a lot of users, a lot of repositories. They are a very large organization. So if you are a small organization or you're not at the scale of GitHub, a lot of the stuff that we're talking about in this blog post are going to be very relevant to you. So let's look at the timeline of how things panned out, right? MySQL was launched. MySQL launched version 8 sometime in April 2018. Now GitHub has been founded in 2008, I think, and right from the start they've been using MySQL. I don't know what version they started with, but somewhere in the blog post they do talk about upgrading to version 5, which they were using before they had to upgrade to version 8. MySQL came out with version 8 in 2018, and in 2023 October is actually when they decided to end live support for version 5.7, which is what GitHub was using. So because in October 23 they were going to end the support for 5.7, GitHub started preparing to jump to version 8 in 2022. Now they started in July 22, and it took them over a year to finish the upgrade. You can imagine the amount of time, the amount of resources that had been put into this for just a simple version upgrade, and you'll see why it is not so simple. When we talk about upgrading versions, engineers tend to forget how complicated some things could be. We tend to take things for granted when we say we are just going to upgrade a version, or how big could it be, how complicated could it be. It's just a version upgrade, but there are so many things involved. There are so many things to take care of, especially if you are as large as GitHub, serving billions of users, having millions of repositories. I think they have about 500 million repositories on GitHub, and these are not just public repositories. There are a lot of enterprise accounts as well on GitHub. GitHub has an enterprise plan, so naturally they have some SLAs. They need to guarantee some levels of service. They can't just stop everything and say we are giving everything for free, so we're just going to stop everything and we're going to upgrade, take our sweet time to upgrade, and you guys have to wait for it, right? They can't do that because they don't just have free users, they also have enterprise clients, and these enterprise clients can't afford GitHub to go down, right? Imagine Microsoft itself using GitHub for all of their source code. GitHub is owned by Microsoft, so I'm assuming that is what they use. But any large company, let's say Facebook or Microsoft or Apple or any company, any large company that you can think of, most probably they use GitHub because GitHub is the most widely used source code management service out there. They are using GitHub and GitHub just goes down. You can imagine what happens, right? Not just GitHub goes down, but every single other application goes down that uses GitHub. So it's very critical for GitHub to find out a way in which they can upgrade peacefully or gracefully without affecting any of the users, and they did that brilliantly. I really like this blog post. That's the reason I am talking about this today in 2025 when this post had actually come out in 2023. It's so relevant, it's so interesting, and if you just go through it with me, you'll find out how engineers think through different challenges, how they navigate through different problems, and how you can also think like an engineer who's working at a big tech firm, right? So going back, GitHub started preparing in July 22. It took them over a year, and they didn't say when did they actually finish it off, but it's somewhere between July and October 23, because they said it took them over a year and they had to obviously do it before October 23, so it took them some time before, some time in between. And they launched this and they posted this post in 2023 December. So I think the timelines. So let's go through this blog. I've read this blog for you and I'm trying to explain every single important point so you don't have to. And if you want me to do this more, if you want me to cover some complex engineering blogs, make them very simple for you, just comment down below and I'll read that blog and I'll create a video for you. So if you see, they're talking about how they upgraded their fleet of 1200 hosts of MySQL to version 8.0. Now upgrading 1200 plus servers which are distributed across the globe is no small thing. This is something that took them years of planning. It took them over a year of planning. They had to involve so many different teams into it. The application team, the database team, plan so many different things, look at so many different pieces of the puzzle. Like, jumping from version 5 to 8 means that you're going to change some of your code, you're going to have to change some of your practices. So all of this took time for everyone to implement, right? And like I said, the reason they had to do this is because version 5.7 was nearing end of life, so they had to upgrade to version 8, and they wanted to upgrade to version 8 because that was the LTS version by MySQL at that time. There are obviously many benefits. Every new version comes with a bunch of benefits. They're saying that the new features in version 8 is what they wanted as well, like instant DDLs, invisible indexes, etc. So many reasons to upgrade, but I think the major reason for them was because 5.7 was coming to end of life. Now let's quickly look at some stats. GitHub has 100 million plus developers and 420 million plus repositories. That's a large number, right? There are like 500 million repositories, and you can imagine how many requests they get every day. They have 1200 plus hosts spread globally, and they had 50 plus clusters. Interestingly, when the last time they upgraded from whatever version they were on to version 5, they only had 5 clusters. This time around, they have 50 plus clusters. They have 300 terabytes of data, more than 300 terabytes of data, and they're serving 5.5 million queries per second. You can imagine the amount of pressure the engineers would have had to make sure that everything continues to work well. Imagine 5.5 million queries per second, and if it's down even for 1 hour, you can calculate 5.5 million into 3,600. That's how many queries that are going to fail, right? So each of their clusters are configured for high availability. They had to make sure that their upgrade was smooth and seamless, so there is no downtime, and they managed it. Now throughout this blog, you'll see that they use a bunch of different services. We'll talk about some of them. For example, they use Vitus for partitioning. They use they use Orchestra, Freno, Ghost, etc., which are some of their in-house automation tools that they use, and we'll see how they use Orchestra, and we'll see how they use Orchestrator somewhere down the line. But in summary, they had to make sure that they do the upgrade while maintaining all of their SLOs. Now, how did they start preparing for this journey? What they did is they started with identifying the differences between version 5.7 and version 8. They found out what are the different breaking changes, how do they need to change their code. They found out that there are some changes with the way the permissions are managed, the user roles, etc. are managed. So when they were upgrading, they identified that there are some things that they need to change. The way they did this is they had a parallel version 8 running on the CI environments. So during their continuous integration process, along with version 5.7, they had version 8 running. So that is where they were able to identify bugs, issues, maybe some test cases were failing, etc. And they were able to identify the changes that they had to make as part of the upgrade. Another thing that they had to ensure was, as part of their upgrade, they had to ensure that they are able to roll back. Now between version 5.7 and version 8, there are some breaking changes, meaning version 8 is not backward compatible with version 5.7. The problem now is, if they change all of their code to work with version 8, and if the upgrade fails, they have to roll back the database server from version 8 to version 5.7. Now the code will start to break, right? So they had to figure out ways in which both versions continue to work. For ensuring application compatibility, what they did, they added MySQL 8.0 to continuous integration for all of their applications using MySQL, and they ran both versions side by side to ensure that no test fail, everything is smooth. What they didn't want is to identify issues in production once they have actually released the new version. They didn't want to find out any bugs then, any issues then, but they knew that that is unavoidable, and they'll talk about it somewhere down the line. And they tried to plan for everything, every type of issue that they may encounter, which is why it took them over a year. And what they did is they use GitHub projects. I've never used GitHub projects, but I don't expect them to use Jira because they have GitHub projects, which is their in-house alternative for Jira. So naturally they were using GitHub projects for communication, transparency, etc., so that everyone in the team is involved in the process. Everyone knows what is going on and what needs to be done for the upgrade. Their upgrade plan included a bunch of steps. What they wanted to do was have rolling replica upgrades. Now look at this diagram, right? What they're doing, they're not upgrading the primary host. So they have a distributed system. Obviously they have a distributed database system. There's a primary server, and then there are replicas. They didn't want to upgrade the primary directly. What they did is upgrade the replica, start using the replica in some requests. Eventually the replica becomes the primary once it is ready, and then they replace the primary with the replica. They use orchestrator for this. And if you see in this diagram, they upgraded a replica in place. They enabled traffic to one of the replicas. Then they provisioned more replicas. Then all the replicas in the DC is data center. Then within a data center, they enabled all version 8 replicas and disabled all version 7 replicas. They didn't remove all the version 7 replicas. They kept all of them. They'll talk about it in the next step, I think. They kept the version 7 replicas as is, but they were not accepting traffic. They were just there in case version 8 fails or something with version 8 fails, and they had to roll back to version 7. So they didn't want to bring up version 5 just in time. They kept all the replicas alive, but kept them disabled, so they were just available when they wanted to roll back, if they wanted to roll back. And after a few hours of testing, when they found out when they didn't find any issues with the upgrade, that is when they actually disabled that is when they actually removed version 5.7 replicas. Now if you see, this is how they were managing their replication topology. They started with version 5.7 and created a downstream version 8. Now this version 8 had another downstream, and it had two chains of replicas. That version 8 had replicas for version 8 itself, and then there were some replicas of version 5.7. The green ones are what's active. So there are replicas of version 5.7 which are present but disabled. And if you read here, this is the topology that they maintained for a short period of time, hours at most, until they moved on to the next step. So they didn't just upgrade everything to version 8 and got rid of version 5.7, all the replicas that were using version 5.7. They kept some replicas alive but disabled just in case they had to roll back. Now what they did, like I said, they did not directly upgrade the primary. They upgraded one of the replicas, and using orchestrator they promoted one of the version 8 replicas to become the primary. So if you see what they did, they had a failover primary to version 8 replica. Then they upgraded the rest of the types, and then they upgraded the backups, and then they cleaned it up. So they had the replicas for version 8 and version 5.7 which was disabled. One of the version 8 replicas started getting the traffic. They promoted that replica to be the primary, and then they upgraded the rest of the types, and then they upgraded the backups, and that is when they cleaned up everything and then got rid of all the version 5.7 replicas. Now they did not just have to update whatever is being used by github.com, they also had to update a lot of internal tools. So we are familiar with github.com, which is their source code manager, but they also probably have a lot of internal tools, right, that they use to keep github.com up to date or keep github.com running. So they had to upgrade those servers as well. They had to do it at the same time for consistency. Finally, the cleanup. If everything went well, they did not need to roll back, and they were successfully upgraded to version 8. They had to remove version 5.7 servers. They didn't remove them right away. They let the version 8 servers accept traffic for 24 hours. That is what they call the full cycle. Reason for that is they wanted to make sure that these version 8 instances or servers were able to handle the traffic at all different hours, all the different peak hours that they know of, right? So they kept the version 5.7 replicas in the background, just disabled, available for rollback for 24 hours before they eventually got rid of them. Now, the ability to roll back is what they definitely needed. And here's where things start to get interesting. So this is when they discovered that if they had to roll back for whatever reason, they had to make sure that the servers are backward compatible. For example, they found out that the Microsoft SQL 8 supported some different Unicode character, a collation of Unicode character, UTF-8 character, but version 5.7 did not support this. It supported a different version, a different collation. So that was a challenge. So they had to deal with that. Second, MySQL 8 introduced some roles for managing privileges, but this feature did not exist in 5.7. So they were using some features and they wanted to start using some features in version 8 which were not present in version 5.7 at all. So they can't just roll back because some of these features don't even exist in the older version, right? So what they did, their configuration management was expanding certain permission sets to include role statements and executing them, which brought downstream. So they basically created a bunch of scripts maybe that was managing the rollback, or that was managing some of these roles and some of these statements in case they had to roll back to version 5.7. So they basically wanted to convert everything they did for version 8 back to version 5.7, for which they had some configuration manager. And for the UTF, the Unicode problem, they started using UTF-8 and they are using Rails. So their Rails configuration is what they're saying ensured that it was smooth, that all of these servers maintain the same backward compatibility and forward compatibility, obviously. So because of their Rails configuration, they were basically confident that this will work. So I mean, managing these challenges seemed to be very straightforward. But thankfully, or at least they've only talked about 2 problems that they found out with backward compatibility, and they were both easily solvable, at least for them, which is good. Now, all of this, like I said, I've been talking about all the challenges that they face. There are a lot of challenges they face, and some of them are very interesting problems. For example, they're talking about Vitis, I don't know how it's pronounced, to be honest, but that is their own service which they use for horizontally sharding relational data. You'll see that in the first line. So while they were upgrading the MySQL servers, they had to ensure that Vitis is also upgraded. Why? Because you'll see they use a VT-gate proxy. VT-gate, which is the proxy layer for Vitis. It advertises a version of MySQL, and some client behavior depends on this version information. So Vitis is what they were using for partitioning, and it required to be on a particular version. So if they were to upgrade to version 8, they also needed to upgrade Vitis in parallel, which is what they did. So this is an interesting thing. Now, while they were upgrading to version 8, they found out that MySQL has a bug about replication. They faced a replication bug with MySQL, and then I think they are the ones who created a PR for MySQL and got that bug fixed, and that bug got resolved in version 8.0.28. So they had to make sure that whatever they were upgrading, it was at least version 8.0.28. So not 8.0.0 or not 8.0.27. They had to do 8.0.28 because they faced a bug while they were upgrading their own servers, which led to them fixing a bug on MySQL itself, and then they use it for their upgrade. So MySQL, an open source database, GitHub using MySQL. GitHub wants to upgrade to MySQL, a new version of MySQL, and because of the amount of data that they have, because of the amount of things that they are trying to support, they identified an issue with MySQL while they were upgrading, and that is what they were able to fix, and that is when they actually upgraded, after fixing their own issue, after fixing the issue with MySQL that they discovered by themselves. Apparently no one discovered this obviously before they did, which is why it wasn't resolved yet. So this was a very specific bug. It was only occurring when they were using the system variable and it was set to 1, and that is what they were doing. And they discovered this only when there was very heavy load on the system, and when the systems are very write heavy, and they are saying that most of the clusters are very write heavy. To be honest, until they've said this, before this point in the blog, nowhere they've said that their clusters are very write heavy. They're only talking about availability for reads. So I was assuming that their clusters are very read heavy, but here they're saying that not all clusters are read heavy. Some of their clusters are also very write heavy, and because some of their clusters were very write heavy, they identified this bug, which they later solved, and that is the version that they started using. Some other problems that they faced with backward compatibility and other things is they had some queries that were passing in CI. So I mentioned earlier that they were using the continuous integration process to make sure that the version 8 works well with everything they have going on, meaning with their code base and everything. What they found out is some of the queries which users were in had tens of thousands of values. So if you know how SQL works, you have a SQL statement, say select star from table, where id in, and you give an array of all the values. Some of these queries had tens of thousands of values, which is huge, right? Having a where query where you're looking for a value to be one of the values that you're providing, and the number of values that you're providing is in tens of thousands. I can only imagine this to be one of their search queries, or when you're just using GitHub search to find some data in the repository or across the organization, etc. I'm thinking that is one of the queries that uses this large wherein clause. But whatever it is, they did not identify this in the CI environment, but when it went to production. So what happened now is, and they knew about this, they knew that inevitably they'll see some problems in production which they will not encounter before they release the new version, and they were preparing for it. What they did, they encountered some queries where they were in large where they had very large wherein queries containing tens of thousands of values, and in those cases they had to rewrite some of the queries before continuing with the upgrade process. So during the upgrade they were doing some testing, and during that testing in production they found out that some of the queries are failing, and before they can finish the upgrade they had to fix those queries. For that they use this query sampling tool called SolarWinds. It is a SaaS platform. It is a SaaS database performance monitor, which is what they're using. They say using that they found out that some of these queries are failing, and then they had to go back and change. So the problem that they faced was backward compatibility. The queries that they had written, which work for 5.7 but not for version 8, and then there were some bugs with MySQL as well. These are some problems that they faced and they solved for it. So that is why you can imagine they had to face so many problems. I mean, not so many, but the magnitude of these problems is large. They had to fix MySQL itself, they had to fix their own queries, and there were some backward compatibility issues as well that they had to address. So that is the reason it took them over a year for this upgrade to finish. Now they've talked about the learnings and key takeaways, etc. And what I've learned from this post and what I want to convey is that when you are the size of GitHub, or at least even half of that size, or even just started, if you have some users in production, let's say you just have thousands of users in production, not millions, just thousands, even then you can't just simply upgrade your infrastructure right away. Upgrading something in engineering is not a trivial task. We take it for granted as engineers, saying that okay, version 5 to version 8, what's the big deal, right? I know software companies that are stuck with such old versions that these versions have now been deprecated. There's no support for them, and the developers are not able to upgrade because number one, they don't have enough resources to upgrade everything without breaking anything. It takes a lot of time. One very important thing to consider when you're building applications is to make sure that you are choosing something that is stable. You can see that the stability is not going to change in the next year or so. So when you're starting to write an application, you want to make sure that you choose the most stable version, obviously. Another important thing that they've talked about is how important tooling is. They invested a lot of money and resources in making sure that they are looking at the performance, they're looking at issues, they have very good diagnostic information, and they invested so much into it, which is what made their upgrade seamless. I mean, I wouldn't say seamless, it took them a lot of time, but from the looks of it, from what they've mentioned in the blog, it seemed like they had it all covered. They had prepared for a lot of it, and it doesn't seem like they encountered anything by surprise. They were not surprised by anything, and they were able to smoothly navigate through this. Another interesting thing about this blog is they've linked another blog called partitioning our data, and they're saying that how this exercise that they did years ago, if I open this blog, this is written in 2021, so 2 years before they had to upgrade. In 2021 they said uh, they had to look at partitioning the data, and if you scroll down somewhere over here, you will see that in 2019 they answered 950,000 queries on average. I think this is per second, 950,000 queries per second. And in 2021 they went to 1.2 million queries per second, and if you see in 2023 they had 5.5 million queries per second. So the amount of jump that they are doing, and I won't be surprised the next time they come up with a blog saying that they upgraded from version 8 to some 12, 13 maybe. They have 15 million queries per second, I don't know, and they have like 500 clusters in their fleet. And I wouldn't be surprised if none of these things work for them at that time, but I do know that whatever they did now or whatever they had done in the past helped them for this exercise, and whatever they have done here is going to help them for the next exercise, because they are looking at it from a long-term view. They're making sure whatever they do is scalable, is futuristic, and it won't bring them down in the future. So they are taking a very safe approach, obviously, given their size. Not everyone needs to be so safe. Maybe if you just have if you just launch and you don't have multiple users, you can afford to just launch everything or just upgrade everything any day, and then your users won't even notice because you don't have that workload. So this does not apply to everyone, obviously, but it is a very good piece of engineering blog that tells us that upgrading is not trivial. You need to plan for a lot of things, and they've beautifully explained everything. This is the reason I love reading blogs from GitHub. While I feel that they're not talking about all of the problems that they might have faced, I can understand that some of these problems might be internal. They might not be able to put it out there in the public, but they have covered a lot of things. They've given a very good outline for anyone who wants to take up an exercise like this. And I'm sure if some other big tech company who has not done this yet or might be planning to do something like this might refer to a blog like this, and their engineers would follow some of the practices mentioned here. That's it. Thank you for watching. If you want me to talk about anything else, if you want me to create some videos on some specific topics, do comment them down below. If you want me to break down some other complex engineering blogs, explain to them in a simpler manner, please link them in the comments and I will take a look and I will create a video for sure. Thank you so much. Do like, share and subscribe my channel. See you soon. Bye bye.